Hey, what's up? This is Randy. Today we're going to learn how to solve rational equations. In case you forgot what exactly is a rational equation, we'll talk about it. Here we go. So the first thing that we'll do today is talk about the definition of rational equation, and then we'll do one basic example that involves no factoring, and then our last example will be more advanced, and that one will involve factoring. So most simply stated, a rational equation is any equation that contains at least one fraction, and that fraction has at least one variable in the denominator. So let's look at a couple examples of these types of equations and then solve them. All right, so we need to solve for the unknown variable. Hopefully this doesn't look too intimidating. Also, what I decided to do was give you guys a list of the general steps that we'll follow as we go through these problems. And number one says, eliminate impossible answers. What does that mean? What that means is that we need to find any values for x that will make any denominators 0. So what does x in this denominator need to be in order for the entire denominator to be 0? Well, you can just set 2x equal to 0 and then solve for x, and that will tell you what x cannot be. All right, so there it is. Now divide both sides by 2. All right, x equals 0. So if x is 0, this tells us that that entire denominator will be 0. So in the grand scheme of the equation, x cannot be 0 because we cannot have a denominator that is 0. All right, so there it is. X cannot be 0 because if we divide something by 0, that is undefined. So let's say hypothetically at the end of this problem, we get 0 as one of the answers. We can actually eliminate that answer because we know that x cannot be 0. All right, there it is. Step 1 is finished. Now it says cross multiply number 2 to get rid of fractions. So in order to have a fraction both on the left and the right, I'm going to rewrite 7 as 7 over 1. All right, so there it is, 7 over 1. Now we're going to say this numerator times this denominator equals this numerator times this denominator. All right, there it is. We just cross multiplied to get rid of the fractions, so we can cross off this second step. And now we need to manipulate the equation until the entire left side is equal to 0. Before we do that, let's try to simplify both sides if possible. This left side cannot be simplified, but this right side simplified would be 14x. So now, how do we do step 3? When it says manipulate equation until entire left side is equal to 0, that means that we need to have everything on the left side and only have a 0 on the right. So how do we get 0 on the right? We just go minus 14x and minus 14x, just like that. So on the right side, we'll just have 0, and on the left side, it will give us negative 10x minus 2. All right, perfect. Number 3 is done. Now we just need to solve for the variable, which in this case is x. So let's go, first of all, plus 2 and plus 2. And that will give us negative 10x equals positive 2. And lastly, in order to get x alone, we're just going to divide both sides by this negative 10. And what is this 2 over negative 10 simplified? Well, that would be negative 1 over 5. So there it is. We just did number 4. So what is the value of the unknown variable? The unknown variable, in this case x, is negative 1/5. That's the answer. All right, now let's do a harder example. All right, once again, we need to solve for the unknown variable. This time it is n. Now, let's start with step 1, just like in the previous problem. How do we eliminate impossible answers? The way I think about it is if this entire expression, n plus 1, is 0, then the entire denominator will be 0. Now, if just this expression, n plus 1, on the right side is 0, 0 times this will still make the entire denominator 0. And the same thing goes for n plus 2. If this expression, n plus 2, is 0, then it's going to be 0 times all of this, which will make the entire denominator 0. So if this expression, or this expression, n plus 1, and n plus 2, if any of those equal 0, then that will make a denominator 0. Now that was really wordy. Another way to think about it is that we just need to set this equal to 0 and solve for n, and then set this equal to 0 and solve for n, although those are the same, so we really only need to do it once, right? Because they're both n plus 1. And then lastly, set this equal to 0 and solve for n. So right here, let's go minus 1, and again minus 1 on that right side, and we get n equals negative 1. Same thing for that next equation, n equals negative 1. And then right here, minus 2 and minus 2, in order to get n alone, we get n equals negative 2. So this value for n, or this value, will make a denominator 0, which means that n cannot be negative 1, and n cannot be negative 2. Okay, perfect. We have now eliminated the impossible answers. So now let's cross off this 1 right here, and now we need to cross multiply to get rid of fractions. So as usual, we're going to say this numerator times this denominator equals this numerator times this denominator. And I see that we have an n plus 1 on the left and an n plus 1 on the right. So if we divide both sides by n plus 1, it'll disappear. So we can just cross out n plus 1 on both sides because they cancel each other out. So we're left with n minus 3 times n plus 2 equals 4n minus 6. The point is, we want to try to manipulate the equation eventually until the entire left side is equal to 0. What could we do? Well, in order to get this right side as 0 so that the entire left side equals that 0, we're going to need to subtract 4n and add 6 so that all of that becomes 0. But before we do that, let's multiply these two binomials, and then we will subtract 4n and add 6. So here on the left, we have n times n is n squared. And then we have n times 2 is 2n. And then negative 3 times n is negative 3n. And then negative 3 times 2 is negative 6. All equals 4n minus 6. So now let's subtract this 4n from both sides and add 6 to both sides. All right, there you go. Step 3 is done. We have now manipulated the equation until the entire left side is equal to 0. Here is the entire left side equals 0. So now let's simplify this left side and see how we can solve. So let's combine 2n, negative 3n, and negative 4n. That gives us a negative 5n. And then we still have this minus 6 and plus 6 right here. Negative 6 plus 6 is 0, so let's cancel. So we're left with n squared minus 5n equals 0. Now, what can we do to find the value of n, or values of n? Well, we can just factor this side, and then set each factor equal to 0, and that will tell us the x-intercepts of the graph. That is, the solutions. So just for the sake of space, I'm going to erase all this, and then we'll continue working at the top. So right here on the left side, we can factor out an n. So now we have a factor times a factor equals 0. So let's separate this equation into two equations. And that gives us n equals 0. There is one of our solutions. And then over here, we're going to say plus 5 and plus 5, which gives us n is equal to positive 5. So 5 is our other solution. Now it's always important to check and make sure that this solution is not equal to one of the impossible answers and that this solution is not equal to one of the impossible answers. Neither of these are. So our two solutions are 0 and 5. And there it is. Step 4 is done because we just solved for the variable. So as you're working through these problems, I encourage you to be patient with yourself because some problems will definitely be more complicated than others and some will be perhaps more frustrating than others. But remember the rules of algebra as well as these 4 steps that we talked about and you'll be just fine. And that is everything for today. See you next time. Hey.